Okay, welcome to Module 6 of Enterprise, which is Enterprise Design and Integration. Now, to set the context, in Module 5 we talked about how you organize for innovation, for an innovation project, whether it's transforming an enterprise or bringing a new product to market, but anything to do with making a change. And we know, and I've explained throughout, that all innovations are delivered through some kind of an organization, through some kind of an enterprise, a manufacturing enterprise, an engineering enterprise, a design enterprise. But it's an organization of people. It could be a government enterprise, could be manufacturing company, automotive, aerospace. But it's all to do with a people-driven enterprise where you have a series of processes where work gets done. So you can't bring innovation to market in a systematic way without designing the enterprise. So this particular module, I focus on the enterprise modeling itself, the processes, etc. And I'm going to show examples, mainly actually from the aerospace sector, because that's where I did a lot of my work. I've done it in many sectors, but that's where the core pedigree, where I really drilled down into great detail. So looking at the high level business processes and breaking them right down to where engineers did stress analysis calculations, tool design, work, manufacturing process design, process planning, numerical control programming, airframe design, where people actually do work. So this module talks about that, and it teaches you how to actually model the enterprise. So let's start off by looking at the Tier 1 enterprise. This happened to be from de Havilland. When we had to prepare de Havilland for sale, when it was under the Boeing Corporation, basically I was there during the transition from Boeing through to the acquisition by Bombardier. And what Boeing wanted to do, of course, was make de Havilland fit for purpose for sale. They wanted to turn it around. That was their journey, was to actually engage in the regional marketplace, and then they changed their minds. Literally halfway through the de Havilland purchase, they changed their minds and realized that they'd probably made a mistake, that such a company that deals in the large jets really probably has no business being in the regional jet business. It was a different market for them, different culture. De Havilland was a completely different culture than what they had been used to. So they brought in consultants, and they were from KPMG in the United States, and when we merged with KPMG in Canada, Ernst & Whinney, that allowed me access to the de Havilland Business Transformation Initiative. So this is the early version of looking at the company. Instead of looking at it from an organizational point of view, looking at a process point of view, we talked about integrated enterprise concepts in previous slides. So what we said was that the Tier 1 business process was conduct strategic management. These are the top 4 processes, sub-processes here. Develop strategic plans, develop the product strategy. What products will be the Q400, the Q300, this is the Dash 800 series. The Global Express, when it became part of Bombardier, the other regional jets. And then develop operating plans for the actual for the manufacturing divisions. And then the management philosophy, which was basically the policies and procedures that incorporated the values of the company and the human resource policies and so on. So the core business processes is where the real work gets done, and we're going to decompose these in a second. So the first process here is acquire business. So that's where you go out to the government and you ask for money for funding for research perhaps. But typically you're acquiring, and if it's a military company, it's definitely dealing with the Department of Defense, who are the ones that fund these major projects. Or the governments of other countries, Saudi Arabia, for example, buys lots of military aircraft from Lockheed. De Havilland or Bombardier they sell lots of their product to Air Canada, and the governments are always around in the background making sure that these companies are funded. So, but the idea is to go to airline companies and get purchases from airline companies. Then you have to define the product itself. So you have to define the product and the processes to build a product. So this is typically product and process definition. Then you have to build the product and then you support the customer. Look, now the key thing I want to draw to your attention here, look at the language we use. We don't say this is sales and marketing. It primarily is, because engineers are part of it, manufacturing experts are part of it. They're all part of, in the modern times, of creating relationships upfront with the customer and making sure that the requirements definition of the product is clearly defined, and the manufacturing experts would be there to ensure that the engineers realize, yes, we can actually build those requirements, that we have the capabilities, or if we don't have the capabilities, what it would take to acquire the capabilities, because it might require more money. And it's all to do with making sure that the quotation, the price that your company charges is properly defined. So you want the right expertise in cross-functional teams. So we talked about that in previous slides and previous modules. So here is where we actually define the actual product and the process, and that the majority of this is design engineering. So in terms of an aircraft, it would be flight dynamics who establish, the lift requirements of the aircraft, the propulsion systems, lift drag ratios and so on. All these various mathematical relationships have to be established before you actually design the airframe. The airframe has to be reasonably well designed before you design the assembly tooling, and before you design the inside of the aircraft, before you design how the wings get attached to the main fuselage, the tailplane configuration, the flaps, the ailerons. All these things have to be conceptually designed before you start then designing the tooling, but they should be done simultaneously. And that's why we don't show the over-the-wall approach. We don't show it first airframe, then tooling, then manufacturing engineering, or back and forth. We show it as we're going to define these processes as cross-functional, multidiscipline, in order to reduce the decisions that are made and make sure that the downstream decisions when you get to manufacture or building it are also they're not wrong, and you don't have to loop backwards. So the next major process is supporting the customer, often called customer logistics. So it's where you're supporting the customer in the field. And then these are support processes for the enterprise itself. So provide resources, human resources, physical resources, facilities, heating, ventilating, air conditioning, electricity, hydro, preventive maintenance, all that, making sure the machines in the factory are up and running, making sure the IT systems would be in here, making sure that all the IT systems are all up and running and backed up, and there's security systems in place, that you have catastrophe presentations, you've thought through any risks for major, information technology loss, or fire, theft, terrorism. Where is all the intellectual property stored? So this is all the resources here. And then external business requirements. This is your reporting from the accounting department to the government and to the shareholders, and to the shareholders and to the Security Exchange Commission if it's a publicly traded company, which Bombardier is. And then this is providing management visibility. So you want a team there that are also making sure that they're doing data gathering. So today it's called data analytics. So making sure that the data is managed to provide top management with visibility of how work is being performed. So this is what's called the Tier 1 enterprise architecture. Notice it says version 1 here. Now there's a reason for that. Because what we did, when we decomposed the build process, our very first analysis of the enterprise, when we were modeling it, was to model the build process. We didn't do the product development or the product and process development. We focused on the build process. So let me just break that down and show you what it consists of, just so that you know that's not just a fuzzy picture. So the build process consisted of plan for manufacturer. So you define the conceptual manufacturer plan, you develop the tooling plan, develop the facilities plan, develop the quality plan, develop the materials plan, the forecasting. The next one was make and administer budgets, schedule and budget. So you had to do budgets for a particular manufacturing program. In other words, what's the budgets for the machine shop? What's the budgets for sheet metal? Now, after we did this, we realized that a lot of the work centers should be outsourced. So, and people like Bombardier and Boeing and Lockheed and these companies started to outsource much of the component manufacturing, where they became product integrators. This became an overall philosophy of the company, of where the company should place itself. It should place itself as a systems integrator, not as a vertical integrator, but end system, like getting the wings done in Japan, getting the landing gear. Well, it was always outsourced, but maybe outsourcing many of the component manufacturing for machine shop, or even the plastics, composites, and so on. So then the next major task was plan for production, and then the breakdown of that: develop, maintain manpower plan, bar charts, production, loading, etc. Monitor performance of manufacturing. Next one is provide production resources, provide people, provide tools, obtain manufacturing materials, and then actually produce the product, schedule production, control production orders, perform physical production, fabrication. That's just, I might add, that's called B6.3. And the Vice President Manufacturing had to actually create all the detailed processes by which they built the sub-assemblies, the final assembly, the sub-assemblies, the systems, subsystems, primary systems, and integrated them all together on the shop floor into final assembly. So this one process was enormous. It was like 2,000 people working in it. So this is the kind of scale that we're talking about here. We're actually looking at the processes. If it was for Bombardier, for overall for de Havilland, it was about 6,000 to 7,000 people. For Bombardier, it'd be like 25,000 people. So what you're really looking at here is hard to model an enterprise, and its detailed workflow. How do you start, doing it for a company the size, of 20, 30,000? So you decompose these. So what we realized when we were back here at version 1, we realized that once we had multiple programs, if it was a one product company, let's say the Dash 8 400, you could probably get away with this and just have one. You could manage these activities through their functions. But once you have multiple programs, we realized we had to develop a program management office, now called PMO. So we put a new set of processes. We created and we built a program management office at Bombardier Aerospace de Havilland, which then was spread throughout the rest of the enterprise across 4 countries, 4 continents, 3 continents, 4 countries. And so we had conduct program and operational management, and one of the major processes within that is develop an operating plan. Another one is provide program planning management, and then provide master scheduling, or develop a master schedule. So it would be managing all the activities in the acquisition process, in the product design and development process, and in the build process, and in support logistics. So you had an overarching office, and if you just look it up, nowadays it's called the PMO, the Program Management Office. Everybody has one that has a matrix organization. Next thing we did is we modeled the build process. We had a whole year, 18-month-long transformational change where all the processes in build were modeled, identified, and streamlined. And I have all the working papers to this day on that project. But we then embarked upon another very ambitious project, which was to develop the product and process. And we create a series of milestones, M1 to M8, and phases and milestones. So we created a whole product development architecture. The reason it shows that line going like this is because product development is still occurring at the detail level when they're in the early stages of building the aircraft. So when you go to full-scale production, before you go to full-scale production around about here, you're still sorting out a lot of liaison issues on the shop floor. More at the detail now. You're not revisiting the conceptual design up here. That's well sorted out. You're focused more on the snags on the shop floor in building and ramping up to full-scale steady-state production, because there's always snags in the early stages when you're building the early prototypes. So the whole concept of this milestone is, we have these major milestones, and these are not actually the ones from Bombardier. These are just generic. But basically, you have an opportunity identified to sell an aircraft or to sell any product to a customer. You get a request, so you court them. Courtship happens here in this phase, where you ask them what it is they're really looking for. And then if they allow you to go for a request for quotation, they'll ask you for a quotation. This is where you really get down to business. This is more the sales and relationship building and finding out about their requirements and assuring them that you guys can do the job. This milestone is when they actually formally say, right, we want a request for a quotation, and you will know by that stage, if they're serious, that they're not just wasting your time, because they could lead you along in this phase here, and this can take months, by the way, years in some cases, but typically weeks and months, depending on the lead time of the product and the complexity of the product. So you want to be sure that by the time they ask you for a request for quotation, that they're actually so serious that they're not wasting your time or getting you to teach them about your products and then take it to someone else that's cheaper. So this is always something you have to be careful of, and something that owners of manufacturing companies, and any company actually, they're very sensitive. They don't want their expensive engineers spending a lot of time on quotations when they actually don't have the job. So that process up there has to be rethought, maybe with some kind of an expert system, where it is making the customers do the work and not wasting a lot of your company resources and time. So you're, through an expert system, computer and artificial intelligence, you're actually asking them all the right questions, pertinent questions that they have to do all the work, rather than have your key people do the work. But essentially that expert system would have to use downstream engineering and manufacturing expertise, so that these guys are including the right questions to ask up front. So then the next one is the launch. So you've got, by this stage, the order's been provided. 25% of payment is down to show serious commitment, that they're not messing around. Once that money is kicked in, then you get into the conceptual design. And the first major review is it should be really CDR. It's called PDR here, preliminary design review, and then final design review. I'd have probably called that CDR, conceptual design review. Then design verification, release to production. This is just one example from another company. And then disposal. So the very first thing you have to do is define those milestones. So this is an example where activity on the project comes to a stop. Doesn't actually come to a stop. It really should say where activity on a project where a major decision must be made. So a milestone is a distinct state. Typically what happens is when you're deciding whether to move forward or not, sometimes you go ahead here and move forward a little bit into this, but you don't want to spend too much money or people's time in case there's big decisions that have to be made here. You may not want to go, even if they ask for a quotation, you may not want to work with them. They're a company you just don't want to be with. It's the project, you've assessed the project here, the salespeople have brought it in, but maybe you as the engineering vice president or the manufacturing or operations vice president or the CEO say, hey look, there's too many risks with this. Could be in a company where there's chaos, it could be in a company or a country where there's all kinds of chaos. You might actually say, no, it's just the risk's too great, so you kill the project here. So each of these milestones, decisions are made. By the way, the further down the milestones you get, your costs, the amount of cost that you've sunk, meaning you've spent already, are enormous. So up here, before you do M3, you want to get at least 25% of the payment down. And as you go through this, you get progress payments. Now they can hold back about 20% until they've signed it off. and then you have to sometimes chase after that payment. But once again, it's all legally documented, so they have to pay you it once you give them your machine or give them the product that they're looking for. But there's a system, and it's all about this enterprise modeling is about making decisions, making the right decisions. So then, next thing that you do is once you have your milestone identified, you ought to explain the objective of that milestone in your unique circumstance, in your unique company. And then you have to say what the deliverable that comes from that milestone are. So there are several, because there's multiple processes going on between milestones. So you know this milestone is achieved when all the specs and details are accumulated in order to select the suitable equipment, tooling configuration, all necessary equipment eliminated, and complexity of equipment reduced to a minimum. So a request for quote from the customer, suitable equipment and tooling configuration is identified at M2. When you get the M3 launch, this is where it's the customer's written order and a COA, customer order acknowledgement is generated. The best machine configuration is verified. The launch meeting is based on the COA. Long lead items are identified. The output is the business case why you're doing it. So you're going to charge $1 million for this particular machine. Your costs are going to be $800,000. You're going to have a $200,000 profit. That's a big profit, I might add. But you're always looking for 12, 15%, 8 to 10, 12, 15% return on investment, or at least some kind of profit before taxes, EBITDA as well. That would configure into the earnings before interest and tax and amortization equation. So all this adds up from multiple projects into the overall health of the business. So the business case is of course number one, has to make economic sense. And then baseline concept specification, so you know the speed of the machine, the feeds that are going to go into it, the thickness of the materials that you're going to process in the machine, or the aircraft, you know it's a 30-seater, a 36-seater, a 60-seater. You know the amount of seats, that's the big number in civilian aircraft. How many seats are there? Next thing is like, so what size is the fuselage, and what height, you know, the diameter of it? What's the propulsion system? What are the engines? What's the range for these aircraft before they need refueling? All these kinds of big picture questions. Are you going to make the wings of aluminum? Or are they going to be made of composite, graphite epoxy, or Kevlar, or whatever the composite materials are that you're going to use? I mean, there's big decisions are made up front. Then a technical requirements document, which really gets into the technical details of the particular product. Like I said earlier, the speeds of the line that you're making, how many passes, if it's a roll forming line, cold roll forming is another. I use that often as in my examples. And then you have a preliminary bill of materials. Bill of materials is the components that make up the whole aircraft, or the components that make up the machine. Typically it's also called a product structure, and that's the driver of an ERP, an enterprise management system, which is a big integrated information system that integrates all areas of a business. And then the pricing and terms, conditions. So look, I won't go through all these, this is uploaded, but this is how you model the enterprise. This is how you describe the major milestones. In the next level down, you start modeling the phases. So what goes on in between these milestones? So you know what decisions are made at these milestones. Now, let's name the phases. So we said that this was conceptual development here between M1 and M2, and then a proposal, preliminary design, detailed design, detailing, and so on. So these are the phases of product development, and we called it D for definition, for define. Remember from the tier 1 process model. And then the next thing again, this is designing the enterprise. This is the detailed modeling approach. You name the phases, you state the objectives of each phase, you state what you're going to deliver. So for proposal, this happens to be again a roll forming business, to integrate the customer requirements with the scope of the roll forming and equipment and tooling required, to pre-engineer all roll forming equipment, components and line specs, to eliminate all components and options that are not required to meet the customer spec, to define the schedule, the cost, the scope of the statement of work and the resource to achieve the technical objectives. And the outputs of that is a proposal to the customer, some internal documents, and then rough cut capacity planning. Basically, hey, we got this possible order. Do we have they want it for September the 1st, and it's now March. Do we have the capacity where we can actually build that thing on the shop floor? Do we have the capacity in engineering? Do we have enough engineers that can design it? Have we done it before? Can we use previous designs to cut corners? Not just cut corners, but to, you know, save money. You know, the less engineering effort, the better, right? Less time you spend on developing a particular product because it's been done before, then you're saving money. So you keep modeling, you keep explaining what these objectives are. There's the preliminary design phase. Here's the detail phase, which happens between M4 and M5. M5 and M6, and it's called detailing. To produce all necessary drawings and bills of material to manufacture and assemble all components, to create the item masters, the engineering masters, the writings, the numerical control programs. So this is what the engineers, the detailed work. Now the next thing we have to do is model, develop the workflow where these products, these deliverables are created. So these are the outputs: final drawings, item master in an ERP. Visual happened to be the system they used at this time. It's an ERP system called Visual. Engineering masters in Visual. Writings are created, numerical control programs to drive the automated machine tools, the machining centers or robots, etc. But by the time you get to D6, this particular phase, you're actually preparing the shop package, and that's a bunch of work that has to be done. So the next thing is, you want to model the cross-functional processes. So you've now got your milestones identified. You know the critical decisions are made. Now you know the work, the general work and the deliverables that are created between M1 and M2 and M2 and M3 and M3 and M4. Next question you ask yourself, how do we model that? How do we design and develop the actual tasks that humans do? So that's where you get down to the next level. You decompose processes. So decomposing the process from the enterprise level offers control of the cross-functional activities, including mechanical engineering, electrical engineering, hydraulics, manufacturing engineering, sales, production control, and procurement. So you're actually modeling what each of these functions does, and you're doing it in a cross-functional way. Each level breaks down the cross-functional into more narrowly focused groupings, the interrelationship of material thickness, line speed, and motor horsepower. All of these calculations impact the configuration of the product, and it has to be looked at from a supplier point of view, a manufacturing point of view, a process planning, manufacturing, engineering point of view, and a design engineering point of view. All of these people should be talking about this criteria simultaneously, not just throwing it over the wall. So eventually the decomposition leads to a single functional activity. For example, develop a roll form or drive layout. So that would be one, an expert would do that, but he would have to do that and make sure that he connects with the hydraulics guy, the tooling guy, the manufacturer, the trades on the shop floor, tool makers. We have composed from level 1 enterprise to level 4, which is a single task. Let's show you an example here. So here are the cross-functional processes, and what you have here are the names of the functions. So the first one is the customer would be involved in it. Sales department, mechanical design, electrical design, tooling design, roll design, hydraulic design. Again, this is for a roll form machine tool. Just look that up. I think I have a video attached of the company where I did the work, Samco, that you can actually see their products, and there's a video in this module. And you can have a look at that, and it will show you the actual machines and so on that we produced and that we used. That was the machines we produced, and we used this modeling approach to design the enterprise to make those machines. Same principles as for aircraft. So then, basically this is the process architecture of the enterprise. We said P2 was produce systems, layouts, and assemblies. And notice this starts a little bit before M3, and that's by deliberate. Even though the decision hasn't been made to go to the next phase, we're still saying to get ahead of the game, try to meet the deadline, we should probably, you could make the decision, let's start in the conceptual design, or the preliminary design, let us start with a little bit of work before even we have the money down, just to make a head start. You make that judgment because perhaps you know that customer so well that you know they're good for their money. You know they're not going to mess you around and back out at the last minute. So therefore you can make decisions like this where you start into the next phase a little bit early. That's by deliberate. So you define and order the long lead items. So you're not building until round about here. See, when we first created this architecture, we had not modeled the manufacturing, the building of it. We added another 5 milestones in between M7 and M8 for building the product. This was just for product development. And that's interesting because this finished up about 13 milestones. So here you produce the detailed drawings in the NC programs. And this is verifying the product process 5. And this is perform project management of the project management office. I think the next one is we added, this is it. So notice here, we added a whole lot more milestones. So we had release to production and then fabrication complete, assembly complete. So when you're designing your enterprise, notice that you go through iterations for the enterprise model. So we had only 7 or 8 milestones in our version 1 enterprise model, and now we have 12 milestones. I think actually we finished up with 13 or 14 milestones. So you have concept development, the proposal, preliminary design and modeling. We even made the change to that. This is detailed design of the specific parts that are then released to the shop for manufacture. Then you prepare a shop package. Shop package has got the drawings, it's got the writing, it's got the item information, it's got the assembly drawings and so on, and it's got a work order that you can book time to. So the shop package, now that was a physical shop package that we had. We eventually created electronic shop packages. And then fabrication is phase 7, defined D7, D8 was assembly, D9 was testing, and then verification and validation, and then customer support. Now let me just tell you a little bit about testing, the philosophy there. This was not testing a new product, because as you will learn in a future module, I think it's module 8 actually, we're module 6 now, so in module 8 you will learn about lean product development and specifically what the Wright brothers did, how they brought testing at the very beginning. But that's a different. This is testing a known and proven machine. But these machines are very complex. Before you ship it to the customer, it's actually really it wasn't really testing proof of concept. It's not that kind of testing. It's testing. It really was validating that the machine, once it's configured, actually runs and meets the customer requirements. It's essentially setting up the machine ready for shipping. You prove it, you prove the machine itself. You're not testing the design concept. We've done these many times before. So it's not that kind of testing that you'll hear about in lean product development. This is testing, it's fit for purpose for shipment. So then you verify and you validate. After you test it, testing is complete. You validate and verify, it's good to go. It's run its cycles. It's robust, it's not failing, right? You can take it apart or major components of it and ship it and be satisfied that when it gets to the customer site, you can then rebuild it for commissioning, it's called. You can then reassemble a machine. 98% certain it's going to function fine because of this validation work here. So we're back to our concepts, our processes. So we added a couple of processes here. So this is where the work gets done, and then we decompose those further and further down. These are all the functions involved in each process. This one here was the build, verify, and support. So it went all the way from just before M8 and finished at M12. This was really the VP operations, what we call them the VP manufacturing, who would have been running this particular process, but there was lots of engineers who were working up here involved in this as well, because these guys were, their design intent had to make sure it was being incorporated in the build, so you want them part of the team. So then we looked at the actual processes. So we said produce design concepts, what goes on there to define the best suitable method of producing the product based on the customer requirements. Starts with identifying the business opportunities throughout the quotation and getting the order, and then what the deliverables from that particular process are. Produce detailed drawings, produces detailed drawings for all manufactured components, list of all manufactured purchased items and fasteners in the bill of material. You create the item master for each manufactured component in the ERP system, which is then used to drive the bill of material and the routings and the tooling and work center data and so on. Next level, you start doing what the sub-processes of each of these major processes are. So rather than build it up, I'll show you. So consider produce design. So you identify the opportunities, you collect a request for quotation data, you assemble a quotation, you present the follow-up, etc. Now, this one here is a good P2, so you've got the job. So the next major process, define the subcomponents, perform mechanical calculations, the stress, the horsepower, the speed, the line speed, the gear ratios, develop the preliminary layout, develop the main assemblies, generate the legends, meaning the operation station, the stations for the various roles themselves, develop sub-assemblies, and preliminary electrical design. As I move forward in the overall project course, I'll show examples of this. So here were those detailed sub-processes. So define the front-end system, define the pre-punch components, define the entry guide, straightener and encoder, develop the roll former base, define the major electrical components, the drives, the servo systems, the programmable logic controllers, the length control. These were all the detailed processes that we had to identify, and it's these that we model. So once you're right down to this is at the level where humans are doing work. So then the next thing is you then decompose each of these processes into the steps, and then you can code what the steps are. You can assign times to them. So you're still in P2 to develop preliminary layout. So layout and place the junction boxes and cabinets, place the motors, identify new layout based on identified other designs. Okay, so consider P2.1, define the subcomponents. So these are the functions. So this is the whole concept of the swim lane. So this is how you're modeling enterprise. By this time you're down at about tier 3 level processes. And at these levels, you're actually modeling the relationship between those processes. Define the front-end system. That precedes 2.1.2, which is define the pre-punch components and the slag removal. So when you punch a hole in a piece of metal, there's a waste that's called slag, and that has to be taken somewhere. It can't just be let all over the machine. So you have to define the method where that gets taken away out of the machine. So the removal options. Define the entry guide, straightener and encoder. That's P2.1.3. That's here. That's in the mechanical design group. So essentially P2.1 is basically contained within these two functions, mechanical and electrical design. It is a multidisciplined approach. You notice P2.1.2, which is defining the pre-punch system, and P2.1.5 define the major electrical, the drives, the servo system. Because the pre-punch system, you're punching metal, has to know what kind of horsepower is required. So what size is the punch? What thickness is the material? In the mechanical side, and the electrical people have to design their machines around that criteria. So this is modeling the enterprise and showing how electrical mechanical people are working on these, making these decisions. Now look, before we modeled the enterprise, these guys were doing this all the time. But what we were, by designing it and defining it, we were showing the formality of the process. And then when we show these formal relationships, we then ask ourselves, how long does it take them to achieve this, and what faster methods can we use to get these decisions made? Is there a way to eliminate many of these steps, for example, by some kind of expert system? But this is the method by which you decompose the model the enterprise. Next thing you have to do is develop the deliverables. So any measurable, tangible, verifiable item, deliverable architecture, the relationship of one deliverable to another, the logical flow. Examples of quotation is a deliverable, a drawing is a deliverable, the electrical schematic is a deliverable, the bill of material is a deliverable, calculations of horsepower, stress, vibration analysis, and so on. They're all deliverables. This is an example of a deliverables architecture. It controls the output of their interrelationship. So for a proposal, you had to have the die concept designed. You had to have a schedule telling when we're going to ship it. You had to have the pricing. And then the die design was the actual function that created the die concept. Roll tooling had to be developed. So these were the main components of this particular final deliverable. And roll design did the roll tooling. The preliminary layout was a mechanical and electrical design with a hydraulic supplier created the hydraulic design. You needed mechanical, electrical, and hydraulic ready for the preliminary layout of the machine so that you could actually tell the customer what they were getting, at least at a conceptual level. Now at each milestone there was a series of checklists, a list of items to help the process to assure milestone has been achieved. The process of verifying an activity or deliverable has been completed. So I'll just show you an example. Checklist should include the how to check and also what to check. So here's an example. Now it's hard to read, so I'll take it off and I'll blow it up for you. So consider, let's look at 200%. So consider the various functions. So this is M3 checklist, and here you have the customer name. You would put the customer name, you'd have a work order number. So your checklist remains the same from milestone to milestone. So here you have the customer, you have the sales department, purchasing, production control. These are all functions within the company. Each of these are different departments, mechanical, electrical, all different humans, different people, hydraulic, design, manufacturing, engineering. Now, what P meant was, in this particular example for the M3 checklist, that this particular activity here, are customer progress payments up to date for M3? In other words, have you received a 25% down payment? The primary purpose, the primary person to define that is the finance department. Hey, have we received the money? Now, the reason you have sales and mechanical and electrical design in support is because they're working with the customer. So they will know when their work is complete, and they'll say, hey, all my stuff's complete, the payment should be received. They're not waiting on anything from me. So you've got a cross-functional team at work here making a decision. This is how it's done. So here you have sales as the primary person for the next, have all final negotiations with the customer for the order being executed, in other words, or completed. Now, primarily that's just sales. So sales doesn't have to ask other departments or other functions. So let's get another one where there's lots of interaction. You can see primarily at M3 milestone, it's all about the sales department. Now this is an interesting one. Let's see, because it's support from every single functional area. Okay, so this one is 19, number 19. Have budgetary hours and costs been identified and communicated to the departmental heads? Well, this is an internal, this is really saying, have we got our ducks lined up inside? Do you know what your budgets are from all these functional areas to do this job, to do the detailed design of the job before we actually, take the order, before it's firmed up? So the primary focus here is the sales department has to be sure that everybody's aligned with this. And similarly, in this one here, it's the finance, production control. Let's look at that one. P for primary, and then supported by sales in a couple of technical areas. Let's see what that, does the current rough cut capacity support the proposed delivery schedule? So you have to look inside the company to make sure we have enough hours over the next 3, 4, 5, 6 months to actually meet this target date? And if not, do we outsource? Do we run another shift? What do we do? That's really what that's asking. And the primary purpose there is production control or materials management, these guys. There you go. So this is an example of how you do checklists when you're modeling the enterprise. So there's a work breakdown structure of a particular product. You have to consider that when you're doing quotations, and then before you actually put it in the bill of material in the ERP system. So you have a role former system, subcomponents, role tooling, subcomponents, the entry guide, the guide by which the sheet metal goes in at the front. You saw the video. The role former head, the straightener design, how to straighten it up, making sure it's straight as it goes through the roll forming machine to get shaped by the rolls themselves and shaped and bent into some kind of configuration, which again is in the video. And then onto the roll former head design is the head spec, the shaft size, the tooling space, and so on. Okay, so that's the end of part 1, and this is now part 2. And I'm talking about the enterprise modeling for British Aerospace, for BAE Systems, one of the world's big defense companies. I'm only going to go through some of it at quite a high level here to show how this principle was used to model an aerospace defense company. So at that time they were called military aircraft and aerostructures. Now they're called BAE Systems, but they were called military aircraft. So what we did, this is the actual presentation that we used to after we had designed it. This took, I don't know, 12 to 18 months to actually model the enterprise, to define how all the detail processes work. So this was their tier 1 model: acquire business, define and develop product, produce and deliver product, provide in service support, manage the business, support the business. So what we then said was, we started to decompose each of those major processes and we described them. So this is the actual document used in a manual that was used to educate and train the employees. So the business architecture was developed prior to the commencement of the conference room pilot, because we were implementing an ERP system for this company. The business architecture consisted of 10 primary areas. The content of each of the 10 areas of the business architecture evolved during the conference room pilot, and a rationalization of the 10 areas to 6 areas. They are referred to as mega processes, and there they are: manage the business, acquire business. Okay. So you can see, this is a company of 15,000 people. The previous one I showed was a company of 200 people. But it's the basic architecture, it's the same principles. You have to get business, acquire, you design the product and the process, you build it, you support it, and you do it all in a multidisciplined teams. So this was their tier 2, breaking down these major processes of manage the business, acquire business, define the product, and produce and deliver it, support it in the field. This was the breakdown. So let's just go and again look what those are in there. They're not just funny little symbols. So identify target opportunities, develop marketing approach, that's the same one. Deliver the marketing approach. You have to develop it, then you deliver it. Next one. Engage the customer, process customer request, create the proposal, execute and capture the plan, and so on. So let's look at the core processes. So for define and develop the product is define the concept, develop the specs, develop the bill of material, bill of requirements actually, physical product, define the functional product, the support product. So anyway, they're all modeled: inbound logistics, outbound logistics. So let's look and see what they did with this information. So then we looked at what are the major inputs to the whole enterprise and what are the major outputs at the tier 1 level, and we said current strategy, strategic objectives, our market business strategy, our business objectives, bids, contracts and orders go in here, and outcomes product, market, business strategy, partner, supply strategy, business value plan, financial targets, enterprise plans, requirements plans, and so on. So we basically said those were the mega inputs and the mega outputs. Then we said, here are the major sub-processes for managing the business. So managing the enterprise, simulate the actual workload, generate enterprise master plan, generate and release authorizations, develop suppliers, and so on. So this is modeling all the detailed components. These decisions, to give you the perspective, this would be vice president level, and these would be directors to senior managers who would execute these sub-processes. So here's the acquire business. This is the inputs for it. And there's the output, the input, the customer requirements, the market information, the competitor information, the environment information. You know, is there a war? Is there a war? What's driving the market at the moment to want to buy more Eurofighter Typhoons, for example? So there's some mega decisions being made, and then the outputs: proposal outline, capture, and no bid decisions. Hey, we're not going to do this. This is not. Or let's say it's with a country where suddenly the policy relationships changed from the government. The government says, right, we're not doing business with you anymore. We're shutting you down. We were going to build some aircraft for you, or we were going to build some components, but no longer going to do it. All kinds of things unfold. So then this is the acquire business breakdown. Identify target opportunities, develop markets, and so on. This is the one for product development. I don't want to just keep going through these. They're okay. I'll do the last one, product development, and move on to Lockheed. So this is define and develop the product. So define the concepts, key concepts. So conceptual design is they're the people that know how our whole aircraft are designed, what kind of speed, maneuverability for fighter aircraft. These are chief, very senior engineers who've been maybe 20, 30 years working on military aircraft and can come up with these concepts. Now, this is not research. This is not research. This is derivatives of existing proven planes where the customer may want certain features, certain weapon systems perhaps in its payload. This would not be what you would do over a 10 or 12 year research program to come up with a whole new aircraft. This is more the steady state. You're in steady state production and you're responding to unique customer needs for a proven concept, for a proven aircraft, where maybe 100 aircraft have been developed. But each aircraft, they've got new series coming out with new features, new functionality, new performance requirements, and so on. So that's what this is. And so the main sub-process: integrate the product, all the components of the product, define the integrated product itself, and then qualify the product. So they lead to the definition of the total configurable product, which is the capability to achieve the customer spec. Sub-processes employed to assist in the analysis of the concept would include operation analysis. Okay, this is part 3, and I have greater detailed presentations on these that I might create specialty videos with. So this is Lockheed Martin enterprise modeling. Enterprise-wide modeling and supply chain. The objectives to develop a new product development in various environments, use the stage gate or the phase milestone to apply concurrent engineering concepts. I talk about those in lean product development in the next module. And then to apply the systems engineering approach. Let's go back. Systems engineering approach applied to enterprise. So this was the major phases of work in the Lockheed Martin military aircraft development. You had concept exploration. Now this is research. This could be 10, 12, 14, 20 years of work. This is where Lockheed's Skunk Works actually would have been included, when they come up with the stealth fighters and so on. This is exactly at the stage where that, even though it shows it's short there, that could be a very long process if it's in research phase and proof of concept. And this is phase 1, program definition, risk reduction. So you're actually, by this stage, you've got proven technologies. And here you're actually looking at specific markets and specific opportunities. And this is the engineering and manufacturing development. By this time, you've got at least your government or somebody has purchased a lot of orders, because you're moving into where the big money's been spent. And this is production and building, production and fielding, deployment, making it operational. These are all mini milestones. These are military mini milestones. Just look, this is conceptual design review, preliminary design review, critical design review, and these are other military kind of reviews. Now, the way Lockheed was organized is that they had these processes. So they basically said there was an airframe team, a vehicle systems team, a software team, because software is a huge part of all aircraft, the avionics systems and so on. And then you have the mission systems team, specialty engineering and system of systems, flight sciences, test and evaluation. So each of these milestones, each of these particular teams had to deliver something. Those dots represented a deliverable. And the idea was to align these deliverables. So the way we did it, this was just another view. We basically said, we looked at all those 10 or 12 super processes, and we said that they break down into the following 5 major processes: weapon systems integration, airframe product definition, air vehicles, procure the product components, and support the product definition. So then we said, so these are the super processes here, and these are the details that goes on. And so it's in weapons, it's concept engineering, product certification. In airframe, it's defining all the data leading to the manufacture of the product. Vehicle systems define the creation and analysis of all data for hydraulics, avionics, electrical, secondary power and environment, and then procurement, managing the procurement of equipment and materials. So then we took the systems engineering approach. So we said, just to go back here, we said instead of this weapons systems team being separate from the airframe team, being separate from the air vehicle team, we said we should have these cross-functional teams, these cross-functional processes. We said produce concept definition, produce the preliminary definition, produce detailed definition, and then build the test articles. So you've all been introduced to the whole concept of the phases and milestones, and then these cross-functional processes. So they had configured their processes around those major functions, and we said, now to get even more multidisciplinary integration, use this systems engineering approach. So then we said, under produce concept, what is it goes into that? So here were the inputs: the customer's input, the business acquisition input, business management input, the dollars. And then we broke that down into its sub-processes, and we said, plan resources, launch and manage conceptual design phase, do a requirements capture. These represent the databases where the information is stored. So we were modeling the enterprise. So this is level 3 process definition. And then we looked at the main tasks: plan, resource, and launch the phase, define the requirements capture, develop the mission, develop target abilities with the customer, supportability, maneuverability, affordability, many abilities. So each of these were criteria that you had to work out. And so these were the tasks. Again, you're identifying those as you model the enterprise. So here's the deliverables: the abilities, the criteria, affordability, lethality, flexibility, availability, survivability. So that included outputs like mission concepts, operational environments. I mean, are you going to use it over the North Pole? Is it going to be used in extreme heat and extreme cold weather? What altitude are you going to be flying at? Is this thing going to be flying at the stratosphere, top of the earth? Are you going to drop, was it for dropping bombs? What's it for? Are you going to be going close to the surface of the earth? All these environmental conditions create environmental forces, gravity, the concept of gravity. How does gravity act at different atmospheres and so on. So the candidate materials list, can your materials last in extreme conditions with extreme stresses and forces? You sure it won't break up at going extreme speeds? Systems concepts, so how are you going to test it? What's the interchangeability? So an aircraft wing breaks off, the whole aircraft probably go down, but let's say the aircraft wing's damaged. How fast can you turn around getting it replaced? They make helicopters from composites. You can fire a missile through a helicopter rotor blade and it won't necessarily destroy it. It will still be able to maintain flight, but once it lands, you'll want to turn that around, change that fast. How fast can you change it? How interchangeable is it to replace blades or wheels or pieces of fuselage and so on that gets shot perhaps? Then you have to come up with the manufacturing strategy supplier. So this was the Lockheed Martin, and there's others. The IT enablers, what are the enabling tools? 3D modeling, requirements capture tools, project planning software, life cycle cost analysis, high level functional models, that shows the actual simulate the aircraft in the field. Airframe optimization tools, trade-off tools. These are all the enablers. So this is produce design concepts. So I'll finish with this one. Weapons systems program manager has to define his deliverables, what tasks, peoples, what they're responsible for. Weapons system engineers who are involved with weights, aerodynamics, stealth systems. So this is the organizational side. You have to define the organization that's going to work on these programs and define them in what phases and stages and processes they're going to work at. And airframe specialist, aerodynamics specialist, structural analysis, designers for the airframe. And then systems and software, flight control systems, avionics systems, hydraulics, electrical systems, environmental and power systems, and so on. So this is the staffing when you're running a program, that you have to come up with all these criteria and demonstrate you know what you're up to, because you have to show your customers that you have the teams and the people and you're dedicated to it. This is the sub-process definition. So this one's for produce design concepts. So 1.1 is launch and manage the concept phase. So understand the clarification of the work package, identify and recruit the required resources. Requirements capture, that's the specific requirements from the customer. Produce the product concept. So you'd have wind tunneling test, I think here. Data about the concept will start to be generated in mainstream engineering application, 3D modeling, but you'd also perhaps have wind tunnel tests. Yeah, there's wind tunnel tests there. Anyway, you break all these down for all these different sub-processes. Then you come up with the inputs. You have this particular process and its sub-processes, and you have the outputs. And you go into further and further detail. So this one happens to be, this happened to be an existing process for propulsion, and this was the skills that were defined, and these were the actual sub-processes and the enabling technology. And what we had to do was to take that knowledge and reconfigure it into a new cross-functional process. I think that's it. Okay, we're finished module 6. So that's basically an overview of the basic approach to enterprise modeling, and going right down to the detail of defining the software and the technology used on the project, or on the projects for the products, but also on the processes by which you design the products and build them. Okay, thanks very much. I'll see you in module 7.